All right, so we're going to continue practicing derivatives. And often I think you'll see the product rule taught, but I think the quotient rule is the next thing I'm going to show today. Then we'll do some trig derivatives, and then we'll do the product rule because that's where it really fits. All right, so I have our rules up on the board. We know the derivative of a constant is 0. We know the power rule, including the power rule with a constant. And today we're going to focus on the quotient rule. When we have two functions that we can't simplify to one of the top three rules. And let's be clear, if I write f of x equals x squared plus x to the 7th over x, I would expect my students to start by writing this and taking the derivative of this function, which comes back to the power rule. Let's do some actual quotient rule problems. And the first one I have here is a rational function. It's defined everywhere. When you look at the bottom, you can tell that the domain is all reals. And the first thing I'm going to do is I have to recognize that I'm not going to be able to simplify this. So I look at my d dx quotient rule up here at the top, and I see that I'm going to have the numerator be f and the denominator be g. And you notice, and I probably should only pull this out halfway, once I make that, I just take the derivative of those two functions. And the derivative of 2t squared plus 3t, right here, is 4t plus 3. And the derivative of 4 plus t squared is simply 2t. All right? Now it's just plug and chug. So I write f prime t equals. First thing is f prime. F prime in this case is 4t plus 3 times g. Well, g is 4 plus t squared. Minus derivative of g prime f is 2t squared plus 3t. I got my dead spot here. I'll have to go get rid of my pen and go back to mine. And then g prime is simply 2t. That is all divided by 4 plus t squared squared. All right. A lot of times I might say in my class there'd be some problems you have to simplify, some you don't, depending on the instructions. This would be a problem I probably had asked students to simplify because I can see it's all polynomials. So I would expect my students to be able to do all the multiplication on this term and all the multiplication here, then distribute the negative to both and combine any like terms. And just keeping this video short, I'm not going to do that. That is algebra. Next one, once again, I look at this, I see that there's no way I'm going to simplify this y value, so I'm going to pick my f and g. I think my f up for the top is square root of x to the half plus 1. I turn the radical into a fractional exponent. My g on the bottom is x to the half minus 1. Well, I got to take the derivatives of f and g. Well, using the power rule on those, I just bring the power down and reduce it to 1. Derivative of 1's on both of those is 0. Positive 1, negative 1, derivatives is both 0. And again, y prime is simply f prime, which is 1/2 x to the negative half, times g, which is x to the half minus 1, minus f, which is x to the half plus 1, times g, 1/2 x to g prime, negative half, I'm sorry, I said g, I meant g prime, all over g squared, which is x to the half minus 1 quantity squared. And again, this is a problem that I would say that I would ask my students to simplify. This one, I'm going to actually take a second and do the simplification here because this is a case where it's pretty easy if you don't distribute first. When you look inside, I hope everybody can see that this is a common factor. If you see that as a common factor on the y prime, we could pull it out immediately. So we don't always want to just systemize this. If I pull it out, I get x to the half minus 1 minus x to the half plus 1, all still over, and I'll make this a radical because a lot of times in the bottom we'd want it to be a radical. So I take it back to radical form. And you can tell when you distribute the negative that this term and this term are going to cancel. Negative 1 minus 1, because that's going to be a negative 1 there, is just negative 2. And you take negative 2 times half, So this will all become negative 2 here, and you got negative 2 times this half. Well, so I can write y prime now as negative x to the negative half all over square root of x minus 1 squared. And a lot of times we wouldn't leave it on a multiple choice test. I think it would look a lot like this. And we just did the derivative of that function. A couple more. All right, so you look at y equals that rational function, and you know it's not defined at 0. So its domain is all reals, not including 0. But I see that I can immediately pull that apart and write that as no quotient rule here. And I can write this as y equals u to the 4th minus 2u plus I to the u to the negative 2 by putting u squared under each of these, breaking it back into fractions. And maybe I better erase this so we're clear that I just did this. And then doing the derivative is seriously a 2-second exercise in this case. All right, next one can't be divided. It can't be simplified like the top one. Again, I have to pick f and g. Now, it is important that you work on this skill, I think, to be quick at this. I'm going to do the derivative without writing them. So I know I got to take the derivative of the top. So that's 2t times the bottom. 1 plus square root t minus. Now I typically like writing the top right away. Now I got to take the derivative of the bottom. Derivative of 1 is 0. T to the half is what you see here. So this becomes half t to the negative half. Again, getting good at the power rule so that you can use it in all kinds of applications. And then we get that. Again, there's simplification that can happen there. You can see the derivatives here if that helps you see it. Again, this is simply practice. The quotient rule is something you just have to keep on working on. Keep practicing. Calculus is fun, and it does explain the world eventually.